Hello guys, it is 11:56, which is prime time for calculus time. We're doing the answers to Unit 7 Progress Check FRQ B. That was from Monday's assignment, and I forgot to clear all this out, so let's just do that. Okay. The problem is nope, I deleted the page. We're off to a not great start. And I deleted the page again, so let's just try that one more time. Okay, good. Sketch is all filled. Here we go. Now I got a new pen, so I can actually write on it, and it'd be better. That picture is horrible. Okay, let's go ahead and do this. When x equals, so I got x times y cubed. I noticed that when x equals 0, doesn't matter what y is, because y prime is going to be equal to 0. 0 times anything is equal to 0. So anywhere along x equals 0, I'm going to have horizontal tangents. That's my slope. I also notice that when y equals 0, and x could really equal anything, y prime is going to be equal to 0 as well, for the similar reasoning. So, of those, and now we have 4 points left, so let's go and get those 4 points. Let's just pick one. When x is 1 and y is 1, I got 1 times 1, so the slope is going to be 1. The slope of 1 is going to look something like this. If I do negative 1, 1, point opposite of that, I got negative 1 times y cubed. Y prime is going to be equal to negative 1. So at negative 1, 1, y prime is equal to negative 1. So with the slope of that, let's go and do a negative 1, negative 1. That's really the point that I intended before. Here, if I do negative 1, negative 1, negative 1 cubed is negative 1 times negative 1, that's going to be a positive 1. So these two are the same. We'll just do a little slope here. And I think we can go ahead and elaborate here that 1 negative 1 will be the same as that other green slope. The same as this red slope here. Drink, drink. Okay, so that's my slope field. Whoa! Alright, let's go to the next one. Now, find d2y dx squared. So let's do that first. And then I'll read the rest of that nonsense and say, oh, not nonsense. The rest of that excellent question next. Okay, so let's go and do d dx of both sides here. D dx of xy cubed. Okay, left side is going to be d2y dx squared equals, oh, my hand's in the way. Too bad. This one's going to be a product rule because we have a function times a function. And we're going to need a first and a second, and I'll arrange it as f prime s plus s prime f. Okay, f prime is going to be 1, so we have 1 times y cubed plus second derivative, factor's derivative is 3y squared times something times 1. What goes with that? Oh, times x, sorry. What goes with that 3y squared? I know implicit differentiation. I took the derivative of y with respect to x. Now, that's super weird when I have a dy dx here for the second derivative, so what I can do is plug in my dy dx in. So let me just rewrite this then. I now have equal y cubed plus 3y squared times xy cubed, and then times the other x. Now I could simplify that if I want to. I'm going to factor it instead. So now it's equal to, let's just factor that y cubed out of both of these. Y cubed parentheses 1 in the first term plus, looks like to be left with the 3y squared x squared. You can check that. Now that's my second derivative, so that was the first part that I needed to answer of this question, part B. Now, the long sentence here. Determine the concavity, okay, that's why they made me do the second derivative, of all solution curves for the given differential equation. Okay, so determine the concavity for any function given this. given the differential equation. In quadrant 4, oh, that's a weird one. Okay, quadrant 4 is going to be this one. Positive x, negative y. Okay, and then give a reason for your answer. So let's see here. I need to know the concavity in quadrant 4. So in quadrant 4, I can have positive x values. So in quadrant 4, I can have x is positive, but y has to be negative. So let's see what happens if I plug in x is positive and y is negative. I want you to note, when x is anything, this value, when x and y are anything, this value is always positive. If you're not sure, something times something is going to be a positive number, something times something is going to be a positive number, times 3 is a positive number, plus 1 is a positive number. So we get one big old positive here. The y cubed, when y is negative, well, if I take a negative number and a cube it, I get a negative out. And negative times a positive is a negative. Not a negative 1, but a negative number. So, my answer is when quadrant 4, so let me back up here, d2y dx squared is going to be negative, which means the solution curve, okay, negative second derivative means, okay, is CCD, because is concave down in quadrant 4. In quadrant 4, because x is positive, x is positive and y is negative, which means the second derivative is negative. And I'm just going to move this little part over here. Let's see if it will do it. No. I'll just erase this. Just to make it a little bit cleaner and more sensical. Solution curve is concave down in quadrant 4 because x is positive and y negative, which makes d2y dx squared less than 0. Okay. And that's the answer for B. C. Okay, now for C, it says dy dx equals xy cubed again. Find the particular solution to the differential equation. So I'm solving for y here, which means I need to separate and integrate. So let's go ahead and do that first. Dy dx equals xy cubed. Just write everything down here. And let's just go and move this y cubed over here. Doink. Let's go move this dx over here. Doink. By moving that y cubed, I'm going to get 1 over y cubed. Dy equals x dx. Okay, that first step is called separate. Next, we got to go integrate. Okay, too much singing, Mr. Leggett. Way too much singing. It's only 12:03. Alright, antiderivative of x is going to be x squared over 2 plus c. Antiderivative of 1 over y cubed, I'm just going to do some side work here. Antiderivative of 1 over y cubed is the same thing as y to the negative 3 dy. And that means that if I do the power rule here, I get y to the negative 2 over negative 2. So that's my antiderivative here. So it's going to be negative y to the negative 2 over 2. I could rewrite that actually. I'm going to rewrite that instead as negative 1 over y squared. Okay. Got it. Alright, now let's go to plug, I need to find the particular solution, so let's plug in f2 equals negative 1. So I gotta plug in 2 and negative 1. 2 and negative 1. So we got 2 squared over 2 plus c equals negative 1 over negative 1 squared, which is 1. Let's see what this gets here. Negative 1 equals 2 plus c. I got c equals -3. I hope I'm right, because that would be super embarrassing. Ooh, creepy. As I'm writing here, my daughter's paintings are falling off the wall. Ooh, okay. It's okay. A big boy. I'm a grown man. I will not be scared. A little bit scared. Okay, let's see. 4 divided by 2 is 2 minus 2. Okay, looks good. So now what I'm going to do is I'm going to plug that number back in. It's a -1 over y squared equals x squared over 2. And then we got a -3. And now what I need to do is I need to solve for y. To solve for y here, I'm going to just multiply everything by 2 here just to get rid of that fraction here. So I got -2. I'm just going to go black now. So this last step, I'm just solving for y here. So it's just some algebra. -2 over y squared equals x squared minus 6. Okay, looks good. Next, I'm going to divide by this part and multiply by y squared. Okay, so dividing by x squared minus 6, multiplying by y squared. When I do that, I get -2 over x squared minus 6 equals y squared. And then I have to do one more step to solve for y and take a square root of both sides. And I get y is equal to a -2 over x squared minus 6. And let's see what the, I need a -1 out when I plug 2 in. I need to make sure that I get a root, because again, when I do a square root, I could get a plus or a minus, and I need to choose which one that is. Alright, so again, it was a 2, -1. So let's plug in 2 for x. 2 squared is 4. 4 minus 6 is -2. -2 divided by -2 is 1. Square root of 1 is 1, but I need -1 out, which means it's going to be a negative root. Okay? Now, I feel like they may have something about a domain here, but I won't go into that. Sometimes I see questions pop up on these FRQs where it says, also state what the domain is for the function. But I don't think they're making you do that here, so we'll leave that alone. That's my answer for part C. I'm just rereading the problem to make sure I didn't miss anything. I also will do that other problem for those people that did it. So if you did the other problem, oh, go ahead, so faster. Okay, holy moly, that's a lot of work. Okay, let's go ahead and do some sketching. So here's 0, 1. I have to just follow the curves here. Oh, that's weird. Alright, I'm going to skip that 1. I'm going to go 0, 5 over 2 first, because that looks way easier to graph. Oh, let's see, it looks like it just goes down here. It looks like it goes up. And it looks like it curves. And then it looks like it just drops. And it looks like it goes like this. Oh, wow. Yeah, something like that. When x equals 1, I mean, it doesn't look like there's anything going on. It really just looks like it's this. So we'll have to see if our answer is right. We'll come back to this one. Let's go to B. Oh, write an equation for the tangent line. I got that covered. Equation of a tangent line. I need a slope. And I need a point. And I have a point. I have 0, 5 over 2. So I can set that part up already for my answer. My answer is going to be y minus 5 over 2. I don't like writing fractions like that. Y minus 5 over 2 equals some slope, parentheses, x, minus 0, which is just going to be x. Okay, so all I really need here is my slope. M, y prime of that point. So let's go and get that value. Let's go and plug in 0, 5 over 2 into dy dx. Eleni, remember there's a way to write it. Eleni hates that I have to write it. We have to write it this way. She almost killed me when I did that one time in class. Okay, 5 over 2 minus 1. And then times, let's see, x is 0, so 0 plus 1. And then times cosine of a lot of nonsense. 0 plus pi, cosine of pi. Oh, yes, unit circle. Oh my gosh, I love unit circle. Unit circle is awesome! Okay, 0 plus 1 is 1. This is 3 over 2 times 1 times negative 1, which is negative 3 over 2. Dunzos! Answer is negative 3 over 2. And that is my equation of the tangent line for the solution curve. That's it. Next. Okay, now find the particular solution. Let's see here. For the particular solution, let's do, we gotta move this guy over here. Again, particular solution is separating and integrating. I gotta get that dx over here, and y minus 1 on the other side. So let's go and do 1 over y minus 1 equals, dy. Oh, gosh, that would have been horrible. Equals x plus 1 times the cosine of x squared plus 2x plus pi. Okay, if you do some sine, first let's integrate before I start talking. Okay, antiderivative on the left is natural log absolute value of y minus 1. I'll let you try to recognize that that's true. For this one, see if you can recognize if I do a u sub here, that u equals x squared plus 2x plus pi. Du is 2x plus 2, which is really 2x plus 1. The reason that's important is because I have an x plus 1, but I have to compensate by a 2. So I need to put a 2 on the inside and a 1/2 on the outside. So when I get this, I get 1/2. So I gotta do a second step here. I get 1/2 antiderivative of cosine of u du. And now I can go and keep going here. I get natural log absolute value of y minus 1 equals 1/2 antiderivative of cosine is sine of u, and u was that monster. 2x plus pi. Don't forget, communism. Okay, so that's the general solution. I want to get the specific solution, 0, 5 over 2. I also want to do, so I'm going to do two things here. I'm curious about that 0, 1 part from earlier. I want to see if it's the line y equals 1, so I'll mess with that in a second. Let's see here. But let's do the question that's asking, which is 0, 5 halves. So when I plug in 0, 5 halves, I end up getting the natural log of 3 halves. By plugging in 5 halves minus 1 is 3 over 2, equals 1/2 of 0, 0 plus pi is pi, sine of pi is 0, so 1/2 times 0 plus c. Okay, so c is natural log of 3 halves. So let's go and get our answer first. So our answer is going to be the natural log, sort of our answer, not yet, equals 1/2 sine of x squared plus 2x plus pi plus natural log of 3 halves. Okay, to free up y, we need to exponentiate, so let's exponentiate this guy. Exponentiate. And that means that this absolute value of y minus 1 comes down here. Okay, here it is. And then I did this in the last video, e raised to a power, any number raised to a power where there's a sum, means that we can break up that, we can break this up into two bases. So basically putting another e here and getting rid of this part, making this a times. And the reason we do that is e to the element is 3 halves, so we have 3 halves e to the 1/2 sine of x squared plus 2x plus pi. Horrible looking one. Or is it beautiful? And then now we'll go and drop the absolute value, but put a plus minus JIC. JIC is just in case you didn't know that. Okay, so now equals plus and minus. Let's add the 1 over 2 just to get everything in one step here, because this turned into a long video. 1 plus or minus 3 halves. E to the 1/2 sine of x squared plus 2x plus pi equals y. And now let's see what point it is. The original point was 0, 5/2. So when I plug in 0, I need 5/2 out. So 0, okay, so this 0 plus pi is sine of pi. Sine of pi is 0. So this is e to the 0 is 1. I have the option of 1 plus 3/2 or 1 minus 3/2. And I need a 5/2 out. So I want 5/2 total. The way I would get that is I need a positive. So my answer is that, 1 plus. If you weren't sure what I did there, I plugged in my initial condition again to check which sign I needed. And I needed the positive version of the absolute value, not the negative value. That's my answer. I'm curious as to what happens to 0, 1, so if you're all done watching and you didn't even do this problem, feel free to move on with your life. If you're curious though, let's just go with it and see what happens here. When I plug in 1 minus 1 here, I get, let's see here, I get 0 on the left. Oh, wait a second. Oh, that's a spicy meatball. To steal a quote from Mr. Aronson. Because 1 minus 1 is 0, I have the natural log of 0. But there is no natural log of 0. That means that this function does not exist at 0, 1. Let me think about that. I'm going to have to come back to that one later to see what's actually going on here. Because that is pretty nifty-galifty. And that's everything, guys. Thanks for watching. Nope. Technical error. Let's try that again.